Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
So remember, we're learning about kinematics, the study of motion. But before we're learning about motion, we've got to describe where things are. So now we want to figure out is there's three ways that we can describe location. So where is something? Where in the world is Carmen Sandiego or something like that, right? And the first one has to do with this course called distance. Now I think we intuitively know what some of these things are, but it's important to define them here. This is the total length of the path traveled, irregardless of distance. So think about your car, and it's got an odometer. And your car might say, my car has traveled a total of 100,000 miles, or whatever it might be. That is considered distance. And this is just labeled simply little d. The second one is position. And this is the location set up with regard to a reference point. So you might say that it's 25 meters north of the library. All right, so that says we know that not only that it's 25 meters, but it's 25 meters, directionally speaking, north of the library. And if you got this from our last thing, this is a vector. And so we say d with an arrow on the top, right? D for distance, d with the arrow gives us the vector for it. And then displacement. This is the change in the position, and it's a vector quantity. And the symbol for this is delta D, or triangle D. The triangle represents change in something. And it equals D, let's say 2 arrow, minus D1 arrow. See, what's happening is we're trying to find how far it has moved. And by the way, I forgot this should be here. So this would be like example, I would say that the fox went from 5 meters east to 10 meters east, 10 minus 5. The delta D is they are now, change is 5 meters east. So here's the weird thing. If you take your car and you drive your car and you come home, delta D, since you're in exactly the same position, is 0. Now your distance, you may have traveled round trip to school and back, 20 miles, but from a displacement perspective, you haven't gone anywhere. Let's take the case of Xavier, who's traveling to Yvonne's house. All right, how far would he have to walk, right? If he's going to walk down the street 110 and 70 meters, you'd say D equals 110 plus 70. He travels 180 meters. That's irregardless of location. But his displacement is different because actually, if you were to draw a straight line, we could figure out that the sine, the hypotenuse, is actually the displacement that he travels. How would you figure this out? Well, a little simple math. You might recall this. There's this thing called Pythagorean theorem that says, a squared plus b squared equals c squared. So I can take 110 squared plus 70 squared, and that equals c squared. So we can add that in our calculator. And we take 110 squared plus 70 squared gives us the 17,000 number, and I can say second function square root of second function answer, the square root, and his actual displacement, as you can see, this is 130 meters. See, his distance is 120, but his displacement is 130 meters. And I guess you might think of this is if he were a bird, right? This is the bird. Mr. Bergman can't draw a bird here. Okay, that's a bird. If the bird would travel 130 meters, but actually his displacement is still 130 meters, but the bird would travel 130 meters. Or we can take the second example. If a raceway is 4 kilometers around, how far does somebody travel if they do 200 laps? So it's an oval, and it's 4 kilometers around. And if he does 200 laps, all right, then he's going to travel 4 times 200 kilometers equals 800 kilometers. So that's equal to the distance. So if he starts at the same place, let's say right here, and he gets exactly 200 laps, what's his position? So this is distance, right? What is about his position? It's 0 kilometers because he's in the same spot, right? And if we look about displacement, the delta D arrow, again, even though he came back to the same spot, so 0 kilometers. Yeah, he traveled 800 kilometers, raced his car around the track, but his position is 0 and his change in displacement is 0. So quick videos to show you a little bit about how we think about distance, position, and displacement.
Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.